geometry friends. I feel like it's been forever since we've spent any time together. Let me welcome you to 11C, where we are going to take a look at surface area and lateral area. So the first thing we need to do is we need to come up with some definitions of surface area and lateral area. And I'm sure many of you are anxious for the textbook definition. I could not care less about the textbook definition. So what we're going to do is we're going to kind of write our own definitions so that they make sense for us. So for lateral area, lateral, you hear the word lateral a lot of times in sports when they talk about like lateral movement. It's side-to-side movement in sports. So the lateral area is quite simply the area of a shape's sides, okay? And it's all the sides added up. The surface area would be the lateral area plus the area of the base or bases, okay? The lateral area plus the area of the base or bases. And we put bases in because some shapes, like a cone or a pyramid, only have one. All right? So there's our two definitions. So far, so great. All right, so lateral area and surface area of a prism. All right, so let's take a look at lateral area and surface area of a prism. First, we have the lateral area formula. This is a little tiny screenshot right off your formula sheet. Okay, so here's your formula sheet, and the formulas that we're going to look at right now. Lateral area of a prism is just the height times the perimeter. Okay, H stands for height. Okay, and P stands for perimeter. Okay, and it's actually, and let's be more specific than that, it's perimeter of the base. And it may seem I'm being nitpicky there, but the specifics matter because we want to make sure that we're using things. I know I told my class earlier, understanding the difference between perimeter and base and all these other things, area of the base and lowercase b and capital B, all these things, they come into effect. Surface area, the area for the formula for surface area is now, and listen, you can use this formula if you want 2LW plus 2LH plus 2WH, all that. You can use that if you have a rectangular prism. I prefer this formula over here, this HP plus 2B. I prefer that because it works for every prism, no matter what the base is. So if it's a triangular prism or a pentagonal prism or whatever it is, that formula works for all of them. And capital B is the area of the base. And this is why the capital letters and lowercase letters, it matters. Okay? So if you take a look at this down here, here we have some edges, we have an altitude. The base of a prism, the bases of a prism are the parallel sides. They're the parallel sides. Okay? So even if it's not like this one, we would think of it as it's standing up. Even if we laid that down, the hexagons are still the bases. Alright. So what's the difference between surface area and lateral area? Okay. The difference between surface area and lateral area. So let's find the lateral area first. So example 1, we're going to find the lateral area of the regular pentagonal prism using the formula. Okay. So what's the formula? Let's remind ourselves of that. And that is the formula for lateral area. Lateral area equals H times P. There's a key word here in this question. It says regular. The reason that's a key word is that of this pentagon, I only know one side, but if it's regular, all the sides are the same. The height of a prism is the distance between the two bases. So the height here is actually this, because the pentagon on right here, that's one base, and then this pentagon out front is the other base. So this 8 is the height. So right here we have LA equals 8 times, and then the perimeter of the base, so that's 14 5 times, so that's 70. So the lateral area here would be 560 centimeters squared. That's for Miss Ottinger. So that's how we do it. We got to make sure that we understand the height from the base. Okay. Take a look at this one over here, a rectangular prism. I'm just going to do the same thing again. I'm going to count this rectangle here as the base. So the lateral area, and with a rectangular prism, what you choose to be the base can be whatever you want, as long as the height, as long as you stay consistent. So I'm going to think of this just like the one we just did, where that's the base. So the height is now 9. So that's 9 times, and then the perimeter of the base, this would be 12 plus 14, which is 26. Okay, so the lateral area is 234. Let me check my math right there. Sometimes, you know, you guys, you catch me with these math mistakes, and it is embarrassing, let me tell you. Embarrassing, alright? But that one I got right, and there's no units there, so I'll put units squared again, so Miss Ottinger is happy. Alright? So that's lateral area. Let's take a look at surface area. Surface area takes into account the lateral area, but then it adds the area of the bases. Okay, so again, lateral area formula plus 2 times the area of the base. Alright, so here we have this triangle. Okay, we have a height of 8. Alright, and so the first one we're going to take the height times the perimeter plus 2 times the area of the base. Okay. So let's see, we have the surface area equals the height, so that's 8, times the perimeter of one of the bases, that's 4 plus 5 is 9 plus 7 is 16, plus 2 times the area of the base. Now the area of this base is a little bit complicated, and we're not going to take the times to do it in the notes. You're going to take, yikes, hold on, I'm drawing all over the place here. You're going to take my word for it, and I'm going to tell you that the area of that triangle is about 9.8. Okay, and then just some basic calculations. 8 times 16, so we get 128 plus, let's put that down, 128 plus, and I want to write down every step, because if I make a simple mistake, I'm showing my teacher that I know what I'm doing, and I'm giving myself an opportunity to earn partial credit if I mess up on something simple. So then 9.8 times 2, not plus 2, sure, plus 2, and then times 2 is 19.6. And let's add that to 128, and we get 147.6. Okay, easy enough. Alright, let's take a look at this one over here. And get you out of here. So let's take a look. Yikes. Man, oh man, having a day. Alright, so let's get same idea here, okay? Same idea. Surface area. The more times I write the formula, you know, I have the formula sheet, but the more times I write it, the less I have to consult it, and the less I have to consult it, the better for me, because I'm lazy. Alright, so I'm going to stick with this as like a rectangle that's laying down. If you want to calculate it differently, God bless you, do whatever you want. But in my head, I'm going to use this right here as the base, and so that is the other base. Okay, so the height is the distance between the two bases, so that's 12, times the perimeter of the bases, well, that's 14, okay, plus 2 times the area of the base, well, the area of this base is 12. Alright, so the surface area equals 12 times 14, that's 144 plus 24 is 168. Ooh, no, see? That's where you guys get me. 12 times 24, or times 14. I was right. You know, go with your first instinct. My first instinct is usually be awesome. And so I go with that. And then what happens is I am then awesome. Surface area is 192. Alright, let's take a look at the next page. So lateral area and surface area of a cylinder. We're going to use different words and different formulas here, but it's still the same idea. It's the lateral area is going to be the height times perimeter, and the surface area is going to be the height times perimeter plus 2 times the area of the base. The difference is that now we're incorporating circumference and area formulas of a circle, because the perimeter of the base is the circumference formula, and the area of the base is obviously the area formula, but it's the area formula of a circle. So here we're just going to copy the surface area right here, and sometimes you'll see 2 pi r squared plus 2 pi r h. I'm going to write it 2 different ways. You'll also see it as 2 pi r times r plus h, and that's just I've factored out a 2 pi r from the first and second term. So you can see it like that, or you'll see it as 2 pi r squared plus 2 pi r h, either way. And then the lateral area formula is the circumference formula, 2 pi r times h. So height times perimeter, same thing, 2 pi r h. Okay? Let's take a look at some examples. We have right here. So this formula again, so lateral area let's do that one first. 2 pi r h, and then we'll do surface area over here. That is 2 pi r squared plus 2 pi r h. So that's 2 times the area of the bases. Oopsie daisy. 2 times. I'm doing the same thing over and over again here. Let's take it easy. Let's go ahead and duplicate that. We can use it twice. Alright, so let's see. 2 pi r, and we'll leave these in terms of pi just for general simpleness. So this one is lateral area equals 2 times pi times, the radius here is 8.3, and the height is 6.6. Okay, so lateral area equals, and I'm just going to do all of this in my calculator, 2 times 8.3 times 6.6, not 636, 6.6, and I get 109.56 pi. 109.56 pi feet squared. Okay, and then surface area, we're going to take that number, 109.56 pi, okay, and just add to it, because that's this. So now we just need 2 pi r squared, so we just need 8.3 squared, and we get 68.89, okay, and we're going to double that. So we have 137.78 pi plus 109.56 pi. Okay, and this is the surface area. So 137.78 plus 109 point, I don't want to do that, plus 109.56, and so the surface area equals 247, and I want to be sure that since I have never included pi, that it is definitely a part of my answer, and that's feet squared, because it's area. Okay, so let's try another one down here. Okay, it looks like a trickier problem, if you want to call it that, but it's not. We just have to make sure that they've given us the diameter, so we got to make sure we convert that to the radius. So the lateral area is 2 times pi times the radius times the height. So that's 121, which is 242. So the lateral area is 242 pi meters squared. The surface area is 2 pi r squared. So again, that's 121, so that's 242. So 242 pi plus 242 pi, so 484 pi meters squared would be the surface area. Okay, just plugging the numbers in, making sure that's the diameter. I convert it to the radius. Let's see what's next. Alright, so lateral area and surface area of pyramids and cones. Okay, lateral area and surface area of cones. Alright, so let's go ahead and check our formula sheet, make sure we know. First, let's, too far. So pyramids and cones. So these are the parts. Some of the parts are important. We have a lateral edge. We have the altitude. That's from the top, straight down. We have a base edge. We have a lateral face. I think the one that's probably most commonly missed is this right here. This is slant height, okay? So it's literally the height of one of the faces. It's a slanted height, and it's signified with this cursive L there. That's really important. Let's take a look at our formula sheet. For pyramids, okay, the lateral area is just 1/2 LP. Okay, so 1/2 L, that's that slant height P. And then surface area is going to be the lateral area formula, so 1/2 LP plus capital B, the area of the base, whatever the base is. Alright? And then if you take a look, the cone formula is very similar, except for instead of doing 1/2, it's just pi RL. Okay, so pi RL, and then, so let's put that in down here. So the cone, it's pi RL, and then the surface area formula obviously is going to be the pi RL, which is the lateral area, plus the area of the base, which is a circle. So that one will be pi r squared plus pi r l. Similarly, sometimes, like the one we just did, sometimes people will factor out a pi r, so I just want to show that to you in case you ever see it. Pi r times the quantity r plus l, because if we were to distribute this, we would get what's right there in orange. Okay. Let's take a look. So find the lateral area and surface area of each figure. I'm going to help you set these up, and then you're going to do the math, okay? Let's remember our formulas. Make sure you're checking those as we go. It's just those few, so we're good to go. All right, so with this pyramid right here to start. So with the pyramid right here, the formula is, again, there's nothing wrong with consulting your formula. You should make sure you know 1/2 LP. Got it. All right, 1/2 LP. I can do that. 1/2 LP, lateral area, is 1/2 LP. So the lateral area is 1/2. The slant length is 12. The perimeter of the base, it's a square, so that's 40. This is just 6 times 40, so the lateral area is 240. The surface area is the lateral area plus the area of the base. Well, the area of the base is 100. So I add 100 to that, and I get 340. No problem. All right. Little things to check is that, your lateral area should never be bigger than your surface area. That would be silly. Let's take a look. Again, let's check our formula sheet. Cone. All right, so pi RL. Got it. Lateral area is pi RL. All right. So I have a lateral area of pi times the radius here is 6. The slant length is 18. All right, so the lateral area is 6 times 18 is 108. So 108 pi. For the surface area, I'm just going to add the area of the base, which is a circle. So that's pi r squared. The radius is 6. 6 squared is 36. So 108 pi plus 36 pi is 144 pi. Okay? Easy enough? Sure seems easy now. Let's try another one. So again, pi RL, lateral area is pi RL. So here the lateral area is pi times 6 times 10. Not really complicated, okay? That's 60 pi. And then the surface area just includes the area of the base, which in this case is 36 pi, so that's 96 pi. All right? I think this one is probably our first difficult one. Again, check your formula, 1/2 LP, and then what do you notice that we're missing? Okay? You should notice that we're missing 1/2 LP. We're missing that L. We don't have part of the drawing that we need. We need the slant length. Now, some people are going to draw it in. I am one of those people. I think it really is helpful to me if I draw in, like I am looking for this that you can't see right now. Let me fix that. There we go. Now you can see it. We need that. Okay? We have this height here. I know the perimeter of the base is 16, so there's all sorts of things I can do. What I need that slant length, so I have to figure out how am I going to get the slant length. Well, if this is 4, then this right here is 2. And so I can now use Pythagorean theorem. This is 6. I have this triangle right here. I'm looking for the slant length. I know that is 6 and that is 2. So I use Pythagorean theorem, and I get 36 plus 4 equals L squared. So L equals the square root of 40. Okay? And once I have that, I'm going to use that number in my lateral area formula. So lateral area is 1/2 times the square root of 40 times the perimeter of the base is 16. So here I'm going to go into my calculator, and I'm going to get the square root of 40. I'm going to divide it by 2 and multiply it by 16. And 50, and let's go ahead and just say 50.6. Okay, so 50 lateral area is 50.6. Now the surface area is just the lateral area plus the area of the base. That's 66.6. Yikes, not a good number to come up with in math, but whatever. Let's take a look at another one. Here again, we need that slant length. We need, let's see if I can draw it in a little bit better this time. No, you still can't see it. Don't worry. I've done this before. Boom. Okay, so we need that slant length. Well, we know this is 10, and we know this whole base is 16, so that must be 8. So in this triangle, we have something, 8, 10. Well, I've done enough of these that I know that that's now a 6. Okay, so once I do that, it's pretty easy. Lateral area is 1/2 LP. Okay, the lateral area is 1/2 of the slant length, which is 6. The perimeter of the base, which is 16 times 4, so that's 64. Okay, and then let's just make sure we're doing our math right. 6 times 64 divided by 2, and that's 192. Okay, so the lateral area is 192, and then for surface area, we just add in the area of the base. 16 squared is 256, so it's 448. Okay, here we have the height, but we need the slant length. This is 14, so that makes that 7. So lateral area is pi RL. Okay, so lateral area is pi times 7 times, we need that L value. Well, I'm going to use trig. I'm going to use the sine of 32 equals, and I know this is 7. That's the height of the pyramid of the cone, and that's nice and all, but if you go back here, you know, the height would help me if I wanted the volume, but I need the slant length. I need the other one, so I'm not using that. Okay, I'm not using that h for anything. The sine of, and I'm sorry, I'm not using sine either. Yikes. Hopefully you guys caught that before I did the problem. The cosine of 32 is 7 over the slant length. Okay, so then I'm going to have to go into my fancy dancy Casio calculator. I suppose I could use a TI, but I don't know why I would. Let's change this to degrees because radians are something different. Okay, and then let's do 7 divided by the cosine of 32. And we get 8.3, we'll call it. Okay, so I go back in here. That's my slant length now, 8.3. I know you can't see that. I'll move it so you can. Okay, and then let's go back into our normal human style calculator and just do 8.3 times 7. I get 58.1. So the lateral area is 58.1 pi. Now for surface area, we're just going to add 49 pi to that, because 7 squared is 49. So that's 107.1 pi. Alright, let's take a look at the next page. So spheres, you have a formula for spheres on your formula sheet. It's right here. Spheres don't have a lateral area because it doesn't have sides, unless we have a hemisphere. That's a sphere cut in half. But spheres, just the formula is 4 pi r squared. So really simply, if you were finding the surface area of this one, the diameter is 20, so surface area, yikes, surface area would be 4 times pi times 100. So it's 400 pi. Pretty simple stuff. If we were finding the area of a hemisphere, we would do the surface area, which is 4 pi r squared, and then we would cut that in half. And then to that, we would add the area of the base, or the area of that half part, which is pi r squared. Okay, so here's what that looks like. This is a radius of 6, so that is 4 times 36 is 144 over 2 pi plus 36 pi. So this is 72 pi plus 36 pi, and that's 108 pi. Okay, this is for the surface area of that hemisphere. Pretty simple stuff, guys. Hopefully you're having a great break. Hopefully you're missing me as much as I'm missing you. We'll see you guys soon. Take it easy.